This should be a lot better. Is that, how are we looking? Should be like way, way, way better. Yeah, okay. Yep. Okay, I was playing around with the encoding settings over the weekend, or it's Thursday, so 2 days ago. And it I guess it didn't work as I thought. Funny how that works out. I was trying to get the VOD to look a little better, so the recording part of it, I've been trying to get that looking more acceptable, but I think it's fine. I think it'll do all right. I think the hard part of it is like, everything's gonna get compressed anyways, so I'm how much quality do I really need? So that's kind of what I've been trying to figure out and get right. Um, yeah, yeah. All right. I'm glad that that's better now, though. Cool. All right. So a little heads up on what we're doing today. Um, we're gonna do um, we're gonna try to work on like standardizing our benchmarking a little bit. So for context, this involves a couple things. First of all, we got to add like better flags to like command line argument parsing and things like that, and look at what that looks like. We have to add what's the other thing we have to do? Oh, we have to figure out how to, like output it into standardized format. So I'm thinking like we do like a CSV kind of thing, and then we can, load it all in with pandas and do some Python fun. And then that we'll go into more depth about some how we're gonna make this look nice and pretty and comparable. All right, but here's the cool thing. Just as a heads up, I was able to get this kind of working, and actually safe. But I had to do something I didn't want to do, which is not great. And we can get into that here in a sec. We're gonna clean this up today, I think too, just because I am tired of it. um, the biggest one is this part here. So two things. Before we were reading in the file line by line. Now I've made a concession, basically being like, let's just read the whole file into memory at once, which I don't love that idea, but we'll get to why I did in a second. So we read the whole file in to memory at once, and we allocate a buffer that is the size of the whole thing. So we allocate a buffer that holds the whole file at once, which is fine here. We can see that kind of here. So we get the size, we allocate the whole buffer, we do that. Yeah, it's big. But there is a performance benefit to it, right? Like you don't have to. Actually, there really isn't. Now that I think about it, there really is not a performance benefit to loading it in. It's really it just makes it easier to work with. Is really at the end of the day. Um, and to be honest, it's kind of like how I think Python is doing it. I'm not 100% sure. The other one is a test reader, and that is so this is the new implementation. And what we're doing is first of all, we broke apart some of our functions to be like a little more easy to read. Then the other thing is that I did this split sequence, so I'm basically splitting the lines on new lines. And I have a couple thoughts of why this could make sense, like how this could help us. Basically, because we're doing it like that, there's a potential that we could, if we had like a very large file, we could thread the like the movement of everything. So we can make it so that the each part, we split the parts and then we can, have a thread process each part individually. I don't know if that's really the best use of our time, but like it is something I'm thinking about of like, we're looking at using, this kind of application would be something that we'd use in high performance computing where you have just a lot of memory and a lot of CPU compute. Um, so I think like, scaling it up might be something that was worth looking into. I'm not certain on that yet though. So let's that's not exactly why I did it. It just makes it a lot easier because then we can, as we see here, we can iterate through the lines. And that's really what we're doing here. We're checking if we're at the end. We parse the lines. We do an append. That's it. And so it's a lot simpler, I think. I mean, it's technically the same because like this, I basically took all the parts that I've been copying here, and we've just converted them to like a constructor. Some of the computer CCs come through are, yeah. I can imagine. Yeah, I've seen some pretty cool HPC workstations, and I'm like, man, that'd be pretty sweet. But yeah, so yeah, that's kind of the thought is that we have this part here. We have new, we can parse everything. This new constructor, we can convert to Atom records now. Atom records have the record type thing. We'll get to that. There's also a realization that I came to over the last uh, couple days or so. So basically, we were talking earlier about how there's different types for different formats and how, or like the PDB format is standard TM, and we'll get to why that is in a second. Um, but basically, the to make a long story short, the files PDB files are great because they have a standardized format, but that format is not respected outside of the database, and there's a reason for that. Basically, different scientists have different things that they want from a given file. Like maybe they don't want certain pieces. So, in an effort to save space on these bigger formats, like because you might have files that are gigabytes in size sometimes, to save space, they kind of chop off some of these pieces, which like I think for me as someone who is primarily doing web dev these days, it's I'm like, oh, like that's interesting. That's kind of a neat thought to have, that that there's kind of this space saving idea. So that's really what it is. We're kind of looking at that. But we're going to, I think the big pieces here is we have to start benchmarking this, and I'll show you what kind of where we're benchmarking to from a starting point, and then how we're going to and kind of where the performance is right now and why this is important. All right, cool. So uh, this one I think is 227L Druid full. PDB. So this is a big one. It's not the biggest one, but it is a big one, and it is one that is not to spec, and that's very important because we still need to be able to parse those. And you get to see my gross thing because I refuse to install Conda on my computer. Just out of Docker run OpenM, we'll run 10 runs here, and you can see my new. We can do zig build. Well, and here for context, let's do this two ways. So we'll do zig run. So this is going to do a release safe by default. We'll do 10 runs, just because Python was going to struggle. So We'll kind of drag race these against each other, I think. It's not a great comparison, but just for the sake of working through this. Oh, and it crashed today. Nice. Nice. Where is it? I thought I did this yesterday. Oh. I think there's like stuff on here that I don't want. Yeah. I think other is the one. No, that's not it. Invalid character, huh? Let's make sure. I did do this with a longer one. Let's see if that one still works. Or if I broke something in the process today. Yep. So there must be something weird with that file we might have to take a look at. But basically, this file, the one I just showed you, mm step 5 assembly pdb, is a massive file. What is that, 147,000 lines? So that's a big one. It's quite a bit bigger, actually, than even this one, the 227L Druid. This one is only, it's like half the size of it. So, like, and you see, Python on average takes 2 seconds to parse it, and that's including I/O, right? Like, so we have I/O. Like, that's the thing that's kind of hard about this. Their API doesn't let me like do it without I/O, so we have to benchmark it with I/O, and I just think that the Zig is probably going to win on the I/O front almost every time. All right, so we got the 2-second average per line. Oh yeah, let's not do that. And then for me, 0, 1, yeah, we'll do the same 10 runs. We're a quarter of the time. So like it's significantly faster. We got a lot. And if we do a Zig release, we do a release fast, which kind of, as we learned, just takes off the guardrails off of the memory safety. Let me do this. Oh, that was 100 runs. Oh, well. It's 0.04. So it's like significantly faster, despite that. Which I think is kind of impressive. Like we have something here. Now, the thing is we need to standardize it. I am a little concerned that, running this in Docker might be a problematic part here. So I think what we need to do is we need to install some Conda, unfortunately. But I think we're gonna try to do this we're gonna try to do it with Nix and see if it works. Because you can install Python packages with Nix, actually. So this is the package we're using, OpenMM. Unstable is still pretty stable, so let's give it a shot. Let's see. Just switch. Good lord. Yeah. That's what I'm saying. We're moving. So there's a couple pieces we're gonna work on this project, I think. There's let me see if I can find it. How did you install Python? It's system Python, I believe. Let's see if it works with Nix though. Python. Oh. Yeah. I wonder if I have to have like a do I have to install Python on Nix too? The alternative, we're just going to do this with the Nix flake and call it a day. Python 3.11. I think it just like because it's an Ubuntu based system. I think it just comes now because I think that they use a lot of Python under the hood. Uh, that's wrong. Exit. How's I'm better with Nix? I wouldn't say I'm better with Nix. I think I just use it a bit. Which Python 3? Okay. Python 3.11 import OpenMM. How do I import OpenMM? Let's try to do it with the flake, actually. I think we could. Z Python bench. Yep. Z Python. Yep, there we go. Nix flake init. Do I have any? Do I need this here? Let's pull up another project. I always like get really confused whenever I do a flake from scratch. It's like I'm not quite there yet. We're not going to define a package. I don't even know how to package Python in Nix. Actually, now that I think about it. Z. Did I package this? No. Z. What's one that I packaged with Nix? I think Bunigi Go. This is Go though. Fair enough. Flake utils, lib, each default system. So here's the thing I will say about Nix though. I feel like Nix is like I also feel that Nix is like kind of hard for people to pick up, you know. Oh, I use Flake utils in this. F. So then the only one I know, Z commit engine. That's the one. Because I do CI with this one. Okay. And that one's actually cool. If we ever get the time to do that, that would actually be really neat to native build inputs, dev shells. I think that's all we really want, right? Per system. Oh yeah, we don't. So we don't use this part. That's the part that always confuses me. Is like in Flake utils, I don't really. Oh, I also hate that too. Flake parts. That's not right at all, actually. GitHub, Hercules CI, Flake parts. Okay, so we have our Flake. We don't need the CI effects. Are we still using Flake utils here? Why am I using Flake utils? Oh, yeah, make app. Is that it? Is that the only? Yes. Okay, cool. So let's just make this super simple. Um, yeah. Okay, so we have to do a let There it is. Okay, that's what I'm looking for. Let's. Uh. Nope. 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 Copilot, stop it. Leave me alone. Packages. Equals. Is it inherent system? Yep. There we go. There we go. I swear to God. Okay. Thank you. Goodness. Fighting with the robots this morning, you know? Oh. All right. Let's see. Dev shells, native dev inputs. We want dev shells. Because I'm not going to build this with Python yet. I'm not. I have a feeling we're going to need a new version of the glibc. The AI chose violence. It really does. I think the biggest I need to, maybe I should just disable it because I've had so many issues with Copilot just like popping up in Nix Flakes, and I'm like, I don't know what's going on. So I probably should disable it. But all right. So native. I guess we'll do native build inputs. I don't actually know what the difference is between the two. I just kind of with packages. So I guess I'll do Python 3.11. 3.11. And I think we can do, what is it? Python 3.11 packages. Okay, the video freezes every once in a while. Okay. I'll have to give it a. Yeah, we'll take a look at that. Yeah. Let's see. Frames missed due to rendering lag. Skip frames due to. Oh, that's network. Interesting. That shouldn't happen. That's weird that that's happening today. Gives me an excuse to throw fiber in the loop, though. Was it really just this easy? Yeah, as if I needed an excuse. Exactly. Fine. Thank you. Thank you. It is. It is. The hard part is like the fiber isn't the expensive part. It's all the other things that you need for fiber, right? Like I don't. My router can handle it, but I would probably want a switch. So I need a switch, and then I would want. Well, I guess if it's just the one machine, I could probably just like run a single run of fiber just into the router. Just the only thing that's in the SFP port is just a freak, just my desktop or my streaming PC. That would be kind of incredible, actually. That would be kind of fun. Just one big fiber run. That'd be cool. That would be quite funny. Uh, I just have Wi-Fi 6 router that can handle gig wired as well. Yeah. Okay. So here's what happened. I um I upgraded to Unify in the last year, and it was great. It was awesome. It was really really good. It was a little overkill. I'm not gonna lie. It was yeah Yeah, it was. So really, what was happening was I have a home lab I use for a couple things. I wanted something that was a little more reliable. My router was getting kind of old, and I was like, I want Wi-Fi 6. So I bought an access point and a router and a Dream Machine, and yeah, life is good. It's it's so stable. It's kind of scary actually. Yeah, when you go Unify, you're going over exactly. Okay, but here's the thing. You can't see it. There's a rack over here. It actually does make things really nice to work with. It makes it so much easier to have everything organized. I have like a couple, like a server and a UPS and stuff that I want to like keep tidy, and that really helps. So I will suck it up and take it. Like not that it's it takes all that much for me to I want a server rack. Yeah, it is a dream. So here's the thing. I've thought about a couple things. I've thought about just rack mounting all of it. To be honest, I have like I said, I have like one old desktop that's like on a shelf in a server. I have a couple like ARM machine, like Raspberry Pi type things I'm running. And my thought is like, well, what if I just rack mounted everything, right? Just put everything on the rack, throw it under the desk, call it a day, right? Like I was like, that could work. That could be really good. Is that we could have just you know we could just do like the desktop's rack mounted, and then it's like right into the we could have like a 10 gigabit switch that's right into the NAS. The NAS is there too. Like it's all battery back. All UPS. I was like, that would be really cool. And I keep going back on it. I'm like, maybe maybe I'll do that. And it's just I don't know. It sounds like a lot of work. Rack mounts for Raspberry Pis, and you can get one. Yeah, I you're talking. Believe me, I've looked into it. I'm like, man, what would be really cool? Rack mounting all of this. I so here's the thing. I'm just scared of having to move it. I leave my current apartment. I go to a new place. I move in, and they're like the internet. So right now I have like cable internet, so it comes into like any room that I want it to come into, basically, right? Because I can just wherever the modem is, that's where it comes out of. Um, Great, that's fine. My concern is I'm going to move somewhere and they're going to have fiber like the internet's going to come in like a weird spot of the house. Like it's going to come in like the basement or something, and then I have to like run it. And then, my office is in a different room and I have to like figure all that out. And like don't get me wrong. I could probably over-engineer a way to get this done, but we're not, I don't want that to be the case. So, oh man, get me all fired up now, Alcius. I swear, man. Like, ooh, oof. Networking is like where I love networking stuff. It's so much fun. I'm awful at it. I'm not great at it, but it's just like I get to like cosplay being an IT guy again. It gets the adrenaline. Exactly. Yep. I get to go back to my IT life and be like, oh yeah, configuration and all that. Actually, it's proven to be actually a really good place to do to work on DevOps stuff. Like I haven't shout out to the Alta Forestry. I mean, he's kind of BG over there. He's kind of been the one that really got me more interested in it. So like I find that like I've been really wanting to play around with things like Terraform and stuff like that. But I don't want to do yeah get into the weeds of it. Oh yeah. Yeah, no, I'm good. I don't want to get into the weeds. I just want to have enough. Just like I said, I'm cosplaying sysadmin. I don't want to do it. Like my thing is like I want to have a home lab that's stable enough that I can use it and come back to it, and it's like it's fine. That's all good. And it generally speaking, it is pretty good. So I'll take it. It's a win. Let's try to replicate. I think we can just run which Python. Okay, so okay. So we can actually run Python. Yep. There we go. See, so I thought it might be a little different if we ran it bare metal rather than let's can we building uh Zig projects with Nix. Maybe what cross compiling C, Go, and Zig projects with Nix. Oh boy, let's look at an article. Zig provides a native build system. It's not part of the official package manager yet, but we're getting there. Name equals build options. Packages.build Zig. Where's this coming from? Oh, is there just a Zig tests post configure? So here's the thought we could do, Alcius. We could run. So with Nix flakes, you have the ability to do like a flake. I don't know if you've ever seen like a flake test. Have you ever run across one of these? You can do like all of your testing for the flake inside of the flake, and it'll like generate stuff. Nope. Okay, cool. Well, let me show you. Let me show you that. That's kind of cool. Z commit engine. Okay, cool. So if you go to npm flake.nix, so this is so like I said, I talk about Hercules CI a lot, and basically what it does is I can probably pull it up and not dox myself. Let's do that. Yep. Yep. Okay, cool. Oh, pull this one. We can pull it into here. So Hercules CI, sorry for the bright screen that's about to take place here. Hercules CI allows you to use the parts of your flake as a way to run CI. So you can do things like run your flake checks or your tests or Clippy or whatever, which is kind of a neat idea. So if you look under this one here, there's a lot in this, but basically what I'm doing is I define the set of checks. So it runs a compilation check, it runs Clippy, and it runs the next test. So I can do Nix flake check. And this is probably going to take a little bit, but it should pull some of it at least from my cache, but we'll see. It's Rust, so it's going to take like 10 years to do anything anyways, but that's fine. I deleted a 33 gigabyte folder of Rust code yesterday. It was a project I was working on. I was like, I don't know how all the build artifacts got this big, but here we are. Let's see. Oh man. Let's see. But basically, all this is going to do. Yep. So this failed a Clippy check, which is good. So what this does is it actually goes through and runs our checks to make sure that they work. So when we do a Nix flake check, you can actually wrap things like tests, validation, other things in here. So what I'm thinking is we could potentially do Nix flake checks or Nix flake tests to actually generate, basically make a derivation to do like a Nix run, Nix build test, and it could just build a benchmark. Like we could benchmark the code for each side, and it would just like pop out a CSV, and then you don't even need to go into the shell. You don't need to run anything. It'll just pull the file, do it that way. That might actually be really cool. Let me think about that. So yes, we're still on 19 seconds on this time. We'll do a Nix flake as well. yeah, I think it would be cool. I think that would be really neat, actually. Now that I think about it, I'm like, that would be kind of a neat project. I can't believe I didn't think about using Nix for Python before. I ran into so many issues with it because like they're like use Conda Forge, and I was like, I want to stay as far away from Conda as possible. Actually, that sounds great. Okay, I'm curious about something though. Never use Conda. What's the issue? So there's nothing wrong with Conda. Let's get that right. Okay, so Conda, its big thing is it's like a package manager, right? But it does things that like Python can already do. So it manages virtual environments in Python. It does package installation like pip, but also has a feature, and it's what's commonly used in like I've seen in a couple different scientific like areas, is there's this idea of something called Conda Forge, which is like a package management part of Conda that will also install system packages. And I'm like, I don't want that. I really don't want that. And that was the problem. So whenever I would do the Docker file, it would do a Conda Forge install, and it was installing NVIDIA tooling, which is like great, right? Like if I wanted to use CUDA and do CUDA acceleration, then that would be great. I'm running on a laptop with no GPU, like just an integrated GPU. I don't want you to install packages for me, and like it's meant for ease of use rather than like really thinking about like what am I actually installing. So like I kind of like that from Nix's perspective of like I kind of have to know what I want, and that'll be, that's what I want. It's also hideously slow. It's ridiculously slow. It takes forever. I wonder if we have to do. Can I just do a go to def? Oh, so nice. There we go. Yeah. I think the hardest part with me using Python is the tooling. Is just it's kind of it feels like JavaScript to me. And there's a million tools to do the same thing. So yeah, we'll work on doing cross compiling for Debian on a res. What the heck is going on here? Are they cross compiling Vulkan with Zig? Sorry, I just got a little distracted there. That's wild. We'll look at that in a second. Because that's ideally what we'll do. Okay, so that's cool. Let's do some timing. So we'll do import CSV, um, CSV output, um, Python. We're just gonna make like one big. Let's do with. Uh, cool. As time file. Okay. I want a CSV writer. Yep. Uh, time file dot write. Oh, there's a better way to do this. Don't come on. Let's run time. I guess that would be the way to do that. And we could probably add a file here because like eventually we'll probably want to add multiple file. Right row is unknown. What do you mean? Oh, we need a writer. Okay. So timelines, time file, time writer. Yeah, great. Let's do run time file. And then we'll do this here. Time. We don't want this to be 0 index. We'll do 1 indexed. Divided by. I guess we'll leave it in nanoseconds. That's fine. Yep. Python main.py. Let's see if it runs. Yeah, not as slow, but still, yeah, yeah. Like let's see. Do I have? So I'm wondering why I can't read that one. Actually, 227L truthful. I wonder if I like accidentally edited the file. Nvim source main.zig. Wait, it's 22. I think it's the same. Yeah, let's try this one. I mean, when you look at it like that, it's it's kind of ridiculous. Yeah, you want to see something that gets even crazier? So here's the thing I'm wondering though. I wonder if my Python it is crazy. It is. And that's the thing is like I'm looking at the new implementation. Like we're literally doing the same thing. Like parse line is creating a line. It's parsing the fields like we were before and doing that. Now, so this is the ultimate goal. Ziggy Pie Dust. Ziggy Pie Dust is a framework for writing native Python modules. So my goal is we write a Python module that's completely compatible with the one that OpenMM is using here. It outputs out a Python file, a Python class that we can use, and it just gets completely built. So like in this case, they do one like classes. So like it's building the class, there's a constructor, stuff like that. So then that way I can basically outsource this to I can just wrap all this in a Python class and then you get that Zig performance like that. Now the only thing I'm kind of like leery about is and that's why I wanted to stop using the release fast even though it is significantly faster. I don't really know about what it looks like about how um how that's gonna work. Like if it lets me compile it with release fast, or if it's gonna make me do it. I think there's a way that we can do it in here, but yeah. But basically, the goal is we can build a Python module that's completely compatible, and we can graft it into their project. That's the thought. Is that we could just basically write a fast PDB parser that OpenMM could then say, if you want to, you can use this one, and you get like a significant performance increase. You know, I doubt that anyone's ever going to use it because it's like you only really read the PDB like once, and sometimes you're like writing into it. We haven't even gotten to the writing piece of writing a PDB yet, and I'm gonna be honest, I'm not really looking forward to it, but we'll get to it. But the goal is that you could like read it all in, and then you could use the Python writer to write it back out if you wanted to. But just basically mapping it to the same Python type. I think we could do that. Um, I think, or write an adapter between the two, right? So like it'll output a type. I have a thing that can convert from one type to another. We can do it that way, and then you get like the performance. You get the performance benefit of just the reading, like the I/O piece. So let's make this a little better. We'll put file. We do want to do args, so I guess we can. Let's put this up top. I know this is not great looking Python. We need to do like the whole if. It's been so long since I've written Python. Is it function main? Yep. It helps if I can spell function. Is it func? Python. Oh, FN. It's FN, isn't it? Nope. It's been so long since I've written Python at all. Like it's literally been the underscore stuff. Oh, it's def. Uh, the underscore stuff. Uh, yeah, I think it's if main. Nope. Uh, if main Python. Oh, if name. So from what my understanding is the point of it is that I guess technically with Python you can like run a file. Like if I had a bunch of functions, I could run a specific function. And so if name main is just saying like if you run the file by itself, only run main. Don't run the other functions. From is what my understanding is because like I could have basically because if I put like a bunch of functions up here, like if I do like def item or something, or if I have code just like sitting and I run the file, it'll run it sequentially. But if I do if name equals main or equals main, then it says if you run the file, run main. Uh, parser dot add arguments. We'll do f file. I guess we want to have the ability to do multiple files, right? So we can do files help equals list files. Too many things here lately. Fair enough. I get it. Uh, I hear you there. I guess for the let's just do for file name. Let's just do for this right now. We'll just do a single file. And yeah. I guess we could do it where we just have multiple files. Like we just say like I can pass a bunch of them. I don't remember how to do that though, but we'll do that at a different time. I can move this out. We'll do that here. Time file. Actually, I guess we can't do that. Yeah, we have to do that here. I guess we can do from openmm.app import pdb file. I guess the only thing I'm thinking about too is like with open. Yeah, I don't really. I think that's good. I just feel like this is not running as I expect it to. The name of the file load can pass an open file object. Oh, if instance is file pdb structure pdb equals a file. If file is instance of file string, open the file. Oh, so we can do this without IO. Interesting. Because I could test it like we can reopen it up top, and then so we can do like file with um, open as f, not f. That read pdb file file. Yeah, we can do that. And then we can do this. And then that way I can actually exclude the IO. Here. Okay, cool. So let's try that and see if it's any faster. I doubt it, but yeah. Because it's the same thing under the hood. Like I hesitate to say, slight question. How do you jump to definition like that? Great question. Let me show you. So I'm using NeoVim, and you can do the NVim LSP. And so I have it mapped to GD. That'll do go to definition. And I can show you in my NeoVim config. There's a lot in here, so just keep that in mind. I think LSP go to definition. Yep. So yep, it's just vim.lsp buff definition, and you can just do like go to definition on that if you have the LSP installed. That's the kicker. Let me drop my dot files actually. So there's two different ones. Feel free to take a look. That's why I keep them public. Some of this probably isn't updated yet, so just keep that in mind. I'll try to get that up soon. So there's two different files. There's two different places here because we're in the process of migrating from my old file, like my old way of doing it, um, to the new way. So one thing I will say, if you don't use NeoVim, if you use NeoVim, if I was to do it again, I'd probably do LSP0. I did something kind of wacky, LSP, where I build this table and load in all of my LSP stuff. I would not recommend doing this in the future. It's too late now. I've already committed to it. So here we are. Yeah. So there's that. But here is my dot files. Um, that's that one. There's a lot of crupt in there, so just be mindful of that. But the nvim part is the part that's good for that. And then here is the Nix version. So I'm in the process of migrating everything over to Nix, but we're not quite there yet. So we'll get there. But yeah. And feel free to reach out if you have any questions about that. Like I am more than happy to talk about getting a development set up, working for you, and yeah, for sure. Yeah, yeah. No. Like here's my thing. So I am of the belief that development, your tooling should match what you want, like what you're looking for. And if you are interested, like if you want something to work for you, then it should work for you. Find the tool that works. And for me, NeoVim is what's worked. I've been using it for quite a few years now. I loved it. I started on Vim, and then I moved to NVim 0.4, and now we're like what 0.10 almost. Um, I like it. It works really well for me. It's fast. It's efficient. It gets done what I need to get done. I really like it. But if you ever have any questions about setup stuff, how do we want to build environments? Um, please feel free to let me know. I am more than happy to go through that. So, yep. Yep. Like I said, there's a lot of stuff in my NeoVim config that's not necessarily great, but the places that I would look at are the key binding stuff. The plugins are kind of there. So the interesting thing I for my mapping is I use this project called WitchKey. You know where to find me. That's right. And honestly, the thing is like I have some ideas of like how we could kind of do some videos for it as well, because I think that it's something that we don't talk about enough. Like, I think that a lot of times you talk about building a dev environment from the perspective of like how to build a NeoVim environment. And like, I don't think that's like necessarily the case. I know a lot of people that are very successful using VS Code. I know some people that are very successful using Emacs. I want to focus on how do we build environments that work for you for like what you need to do, right? And like, I think that everyone's use case is a little different. Like I said before, I worked in IT before doing dev full time, and I did some like dev work, and my environment just looked very different. But how do I bring tools like NeoVim to an environment like that where it might not be commonplace, if that makes sense. Cool. All right, so I think this is kind of like good enough to be useful now. Let's see, is there a way that I can do like Python packages Nix? Let's see. Install. Yeah, this is Micro Mamba. That's what I was working with. It's crazy. It's crazy. With the Nix packages version of Python, you can have 30 to 40% regression on synthetic benchmarks. There's no way that's real. build Python package. Native build inputs. Okay. API 0.3.0. Propagated build inputs. Wheels. Okay. Source. So I guess we do like the local. So I'm guessing it would just be like dev. Oh, that's why I use flaky tills. Oh. Packages default equals, yep. So we can do this. Then so it's gonna be packages.build. No, Python 3 packages. Python 3 packages dot build Python packages package. I don't know if we really need this to be recursive. I'm actually gonna say it's probably not. I think we can just do. There's a way we can like just specify this from here. There's a way you can like inherit these, so like you can say like, oh, when I do a build, like the dev shell is whatever the build inputs are. I just don't remember how to do that right now. We'll come back to that. Nix flake show. I think we'd have to do this. Nix flake build. Nice. No such file or directory set up to Py. Yes. Because it's not actually a Nix package. Oh. Did it freeze? Maybe. Yeah, so this is not going to work yet because we need a setup.py to basically build the package. So setup. From disutils core. Yeah, we'll have to look into that. Oh yeah, because the preprocessor does things like, yeah. I don't know if this is really what we want. Yeah, we won't do that for now. And we're gonna RM the RF Rust bench because it doesn't really work for our use case because the files that I parsed earlier, like those OpenMM files, they actually don't parse in that Rust bench because of how strictly they hold to the spec. So we'll get rid of that. Okay. Cool. We can probably get rid of the Docker file as well at some point. Cool. All right, I think that's what we're gonna call it today. Unfortunately we didn't get so much Zig today. Um, I'll work on that as well. We'll probably do nixifying that as well and trying to get the CSV stuff working. I feel like I'm probably gonna have to write a CSV writer. Like we're probably gonna have to figure out how to write like a basic CSV writer. I think that should be fine though. I think that'll be okay, but we'll see.